Hello, all. Welcome to the show. I'm Gus Gagliardi, and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Welcome to episode 22 of Fire Code Tech. In this episode of Fire Code Tech, we have Christina Francis. Christina is a fire protection engineer at Procter and Gamble. In this episode of Fire Code Tech, we talk about a bunch of really neat and popular topics in the industry like storage, Internet of Things, and smart fire suppression and fire alarm devices. Also, we get into Christina's fascinating career and the global impact that she has had as her time as a fire protection engineer. If you're a fan of fire suppression and technology, I think you're going to love this episode. Christina talks about some integration with fire suppression and data and the new way that technology has been able to integrate and make smart decisions with data. And if you have interest with where the future of fire suppression is headed, I think you're going to love this episode. Don't forget to follow us on social media and subscribe wherever you listen to your podcasts so you never miss an episode. Let's dive into the show. Well, hello, Christina. Thank you for coming on the show.
Thank you. It's my pleasure.
Awesome. So, I just wanted to get started with a little bit about your career and how you got into fire and life safety, if you wouldn't mind giving the viewers a little bit about that.
Yeah, perfect. So I actually have a bachelor's of mechanical engineering, and my first job out of school was with Bechtel. And the first day of work at Bechtel, ever at the Savannah River site, I ended up in a room with three people, and they said one person was going to go to this group, one person was going to go to this group, and then to me they said you're going to go to our sprinkler group. I said okay. Didn't really know anything about that, but that is my great story of how I started in this wonderful industry. Just I joke of maybe that was pre-planned. Maybe it was just the arrangement of how I'm sure it was pre-planned, but no. So I started at Bechtel doing at the Savannah River site and did design and layout a sprinkler pipe. We were retrofitting a bunch of DOE facilities for sprinkler pipes. So I started actually in the field doing design, learning CAD, doing plug and chugging calculations, that type of work, and it was great. And went on from there. Still stayed in piping. Left the sprinkler world for a little while. Went on to do some construction engineering, still all with Bechtel. And then after that, went on to property insurance. So with IRI, which industrial risk insurers, and did that for a few years also. So did that whole insurance loss prevention. I think that kind of hooked me that I was pretty much going to be staying in this industry for as long as I could. And from that, I then jumped into the corporate risk management job or role. And for the past 22 years, I've been managing the global fire protection program for Procter and Gamble. We see all types of, I would say the fire protection world looks a little different, but everything that I learned in the past applies to what I do today.
That's awesome. It's good to hear about your background and you speak about your time in more on the installation side or closer to the installation side of things, and how that experience, I'm sure, is still impacts maybe in some small way how you look at fire protection systems today.
Yeah, absolutely. I mean, I was walking around and looking up a lot, where's the best place to put the pipe, where to hang it. I had some fantastic mentors um, at the time too. You know, I learned very on that just because yeah, you could route the pipe there, but is that the best place, most cost-effective place? Are you still going to get all the what about the calculation part of it? Is that the most best route for the water? So actually we didn't just do it with drawings. We actually had to go out in the field and lay everything out, like literally pipe by pipe. And then, in our office, if there was a design change, the field would always, during construction, the field would call and say, this can't work because, give their reason. And then whoever did the design had to go out to go figure out why, and then, write up a change on your drawing as such, if that was the case. And we really didn't want to have a design change, especially in office, right? You didn't want to be known to the one that always had the changes. But it was truly a fantastic experience. I would say though, back when I started, NFPA 13 was, I don't know, 100 pages maybe, if that. It was, pretty 50 pages. It was pretty thin compared to what it is today. There weren't that many choices of sprinkler heads either. But one of my first days at work, my job was to read 13 and learn it. So that's what I did. I think I still have the copy someplace probably today where, yeah, I read through it, not knowing again anything about sprinkler systems other than maybe an irrigation system that I helped, my grandfather install in our yard or something. And so that was about it.
Man, I could see. I've worked for a fire suppression contractor right out of college, and yeah, that sounds like a great learning experience, but also a contentious situation where you'd have to go out to the field and talk the foreman through your logic on, design change. I know that can be a um, a sticky situation. You don't want to step on anybody's toes as far as explaining why or why not it wouldn't work, and they
Right.
wouldn't be too slow to tell you why something wouldn't work. So
Right. I did have one situation, and I don't know if my manager at the time, you know, put the fitter up to this or anything, but I had a situation where they called me out to the field and said, this isn't. They had, th- not that it wouldn't work, but the fitter decided that they had a better idea and wanted a design change because their they felt that their pipe routing was a little bit better, and I said, yeah. It may be, but mine doesn't not work. And so I wouldn't sign the design change. So again, I don't know if my manager at the time just said, "Oh, let's see, how much I would push back on either." So I didn't. I've never signed the design change and made him change it back to what was on the drawing. So it's just one of those little memorable times for me. So
it's important to know when to stand your ground professionally. So I'm
yeah,
sure that felt like a victory, But
was my small victory. Yes.
yeah, but that's awesome. So I wanted to hear a little bit more about your role at Procter and Gamble. Kind of where you started and where you are now, and maybe a little bit on how things have changed. But yeah, I'm really interested in that.
Yeah, so this is actually a really easy question, as I am doing pretty much what I started doing 22 years ago. Typically at P&G, it's a great opportunity because you come in and you can rotate and grow your career as much as you want internally. I have always done fire protection at P&G, so I came in doing fire protection, and I will most likely retire leave doing fire protection. With that, what's really changed is when I hired in, I've changed organizationally. So I've gone from originally my role was part of our property insurance group, and currently, I've gone through a couple of different organizations doing the same thing, but I currently sit in our global facilities group. So I am in corporate engineering now, which actually is a great place for the technology to be.
Yeah, I really appreciate that background on your time at Procter and Gamble. And yeah, I don't know. I still don't know if I have like a great sense for what a day in the life of somebody who would be in like facilities and like corporate facilities and fire protection from a big picture from such a large company like Procter and Gamble. Maybe you could give a little bit of exposition on what kind of roles in fire protection that you're involved with to paint the picture a little bit, if you wouldn't mind.
My day, it changes every day, obviously changes every day, but there's a little bit out there. It really starts with I look at myself as basically an in-house consultant. So in my role, I set our standards for global standards on how are we going to best protect our businesses. So I actually, for my disclaimer, is I actually look more towards the property side. So property loss prevention and business. So how do we keep our businesses running? Life safety is really held more at our plant levels, and so it's definitely one of those top. Definitely our, you know, one of our principles. But so I won't talk specifically about the life safety aspect of it, but as much as the property control side. So with that, I am looking at how do I consulting for how do we keep our property um, standing and our businesses operating. So we set our standards based on that, and on a global basis, our goals are that we don't have to change our systems every time we change our either products or change our maybe how we're doing something in manufacturing or packing or anything like that. So that once we build something, we don't have to continue to retrofit it. So we look at things, I would say, somewhat in a one size fits all. Obviously, especially with all the stuff that we have out there, there is not one size that will fit all. But we really do want to try to look at minimizing the times that we have to touch the sprinkler systems or fire pumps or any of the fire protection systems. So with that, I say I'm just an in-house consultant. So my customers are our site leaders, my project engineers internally. So my day really it definitely varies all the time. Um, in what I can do whenever I think, oh, today I don't really have much on my calendar today, that can quickly change. Really look at it. What email questions have come in as kind of my first thing is what's happening around the globe overnight, uh, and what questions have occurred. I get everyone's project review. So sometimes, it's just a quick glance, even though it's been reviewed by our third party, a quick look and see what happened on the review itself. There's, some people ask questions specifically to a project. Some contractors, there may have been an issue that something was designed wrong or installed wrong, and then what do we do with that? Um, what is the easiest, again, cost-effective solution while still maintaining our intent to protect? Sometimes there's always, I think there's always new projects that come through to ask a question. So on the design basis, what do we need to do? There's, I could say, questions about temporary storage, even though, I think everyone in the industry could understand what does temporary really mean. Yeah, there are new project initiatives, new products. How would they burn? What do we do with that? All types of of fun, interesting stuff. And then on top of that is just the how do we grow our systems and how do we change them? So, how do we innovate differently to, you know, help our systems, help our sites do things with less touches, with more, you know, more digital innovation, smart technology. How do we grow that system? How do we change something that is very typical into something new so that we're just not standing still with it?
That's awesome. That's really helpful to hear about, or really, and I find very interesting some of the things that you talked about. Yeah, I just would like to go over that point again. That said that you guys like to design buildings for kind of like a one size fits all type of approach for fire protection, but I just wanted to remark like that must present some very robust fire protection systems, with the kind of commodities and things that can be found. I'm sure with the variety of the products, although I'm sure you guys compartmentalize for different facilities, but yeah, I mean, that sounds like you guys would probably be interested in, some of the more um, complex and just more robust fire protection systems if you guys are approaching the buildings in a more of a one size fits all approach, which I mean, I feel like is a common thing in the industry as well. But yeah, I thought that was interesting.
Yeah, our one size fits all really is that we design warehouses for Group A plastic because knowing that we're never, even if we have something with a class 3 commodity today, the chances of that lasting for 20 years is very slim, right? So that approach too. So yeah,
Yeah, that's great. Yeah, I was recently listening to a webinar with the NFPA, and they
yeah,
had,
I would listen
talked
to that.
to,
Yeah, yeah,
yeah, they were talking to
yeah,
that approach, and I was like, wow, in a lot of the projects I work on, we start with, four commodity class four as a baseline, but I had not heard, people saying, start at group A and work your way backwards. So I thought that was pretty interesting.
right. Well, it's easier to manage, right? If you think of, I think in the industry sometimes, and I did listen to that webinar also, where if you're looking to do base minimum all the time of based on what you have at the site, and I think the folks on the webinar pointed it out. Sometimes owners don't know what they have, right? So you're asking a question in commodity classification of we don't really. Sometimes people don't know, and they try to go down to that. Oh no, it's only a class 3. I only want this. Now I don't have to have the fire pump. We must always have a fire pump because we don't have any local water, right? Or avail. So where our sites are located, we're not in the major cities or any, so we're outside or outside of um, more municipalities. So we have water in some cases. In some cases, it's a harder one to get in. So have enough flow and pressure for any system, we'll end up having a pump and tank, and we want that reliability of that too. Because again, without a water supply, our sprinkler systems end up to be decorations, right? Um, so but with that, we look at every time a little change comes or if the incident occurs, having it designed for Group A, we don't have to manage through that. So if there was a change, we don't have to say, okay, you can only store 5 feet high instead of 10 feet high. That's all touches at our sites that add, I would say, unnecessary time costs to it, right? So if I can only store 5 feet high instead of 10 feet high, I've lost half my floor space, right? So it ends up being, I have never done this study, but for the little incremental costs to, treat as um, a Group A warehouse versus a Class 4 warehouse, especially with today's sprinkler heads, I think, we're talking very small, very small. differentials in cost versus the benefits we get. I am not on NFPA 13 committee, but I think it would be great if we had either a very light hazard, or it's either a light hazard occupancy or it's not, or it's a Group A warehouse or it's not, right? Because I think some of our classifications, although they're great and they are real, I don't, sometimes we complicate something that doesn't need to be so complicated, or so exact, I should say, right? I mean, if that makes sense.
Definitely, I completely agree with you about trying to provide, if you're in a situation to provide the premium fire protection solution. And I mean, most people are aware, for existing construction to go back and touch a system. I mean, as far as what it costs to do it for a new construction system, it can be, double or more just to go back and alter that system. And then, that you're dealing with interruptions to operations. And so I can only imagine how those costs can compound very quickly. I definitely understand what you're saying, and I agree. But yeah, another thing that I wasn't aware of, but I somebody at the company I work for said that they had been involved with a sprinkler project with Procter and Gamble before for one of their facilities, and they were saying that Procter and Gamble has their own standards or kind of criteria. I wasn't aware of that.
We do. Yeah, we do. We've had them since I started. Originally, we had a mix of our standards and at the time our property insurance standards. Um, and our standard, our fire protection manual, originally originated really more as giving some training for around the globe. So we had sites globally that really had never heard of, think back 22 years ago, never really heard of NFPA. And we're trying to install an NFPA system when that wasn't there, or it wasn't very common, especially contractors and even for our site leaders. Like, what is it that you really need to know? So our original standards had a lot of training stuff, had a lot of interpreted stuff from NFPA. In today's world, our standards are much, I would say, more reduced. So a standard that may have been 9 pages, 10 pages back in the day, maybe one now, as in it's only for when we differ from NFPA, or we have our own maybe test data of how to protect. So we tried, or if it's something we just really have had issues with, that even though we may be exactly the same as what the industry says, that we want to go ahead and put that into our standard. And as I said, kind of the one size fits all. If we went just NFPA, we could have contractors again debating what type of commodity do we have, and or is this a light hazard occupancy or ordinary hazard. But for us, we have standard densities for our storage areas and for our non-storage areas based on the height of our buildings too. So so it makes it a little bit easier in some cases, because we can just say, if we have a 40-foot high building, these are our only options versus all the options in the code right now. Doesn't mean that we say no to anything in the code, but this is where we try to simplify it.
That's nice that you guys have an established baseline and an understanding of your commodity classification. And I mean, I doubt that you guys could do business without that. But um, yeah, as far as like, owners who might not know what they have, I've seen the gambit of owners, being like, I don't know if we have high piled storage, and they have 25-foot racks, fill in like tires, and they're like, I don't know if we have the high piled storage. I'm like, you guys, you have high piled storage, and in this new
Right.
facility you want to create, and we have to, accommodate that. So. Yeah,
Absolutely.
it's
Yeah.
definitely a knowledge. It's neat for me to hear about how you guys are involved with that process of having standards and criteria and a high bar for fire protection, and
Right.
that's
Right.
something I like hearing about. Yeah,
I was joking after the NFPA webinar on warehousing. I was telling someone that we probably need an owner support group just because, a support owner sometimes get,
yeah,
oh, the owner didn't know. The owner didn't, so, which is true though, unfortunately. I mean, things change all the times and, we can't be everywhere. But we
yeah,
know a lot of stuff, but sometimes not all those things.
for sure, for sure. So yeah, in the vein of kind of like storage and the high complexity fire protection.
Hmm.
Yeah, I mean, you've already kind of explained a little bit about how P&G, tackles some of these the big challenges for the like your storage and manufacturing occupancies. But yeah, I'd wondered if you had any more exposition on how Procter and Gamble and you in your career have tackled these very tough challenges for fire protection systems.
Yeah, so we again we have a diverse group of products, and so fortunately, being a leader in the consumer products world and a variety of business units, we have a lot of things. And over the past 22 years, I've seen a lot of things come in and a lot of things go also. But we take a look at ours. We always, when we look at something new, and or new storage arrangements, we will take a look at, what does the industry say? What's historical out there? What is kind of the loss rate for it? And then how does that differ to what we have today, right? So maybe it's okay. So our packaging may be different, or maybe the only thing that we have out there is the code only allows up to a 30-foot high building, or 9.1 meters, for those non-US unit folks. But what if we want to be higher, right? What if we want to go up to 48 feet? So where do we what do you do? So I think there's a couple of times, or more than a couple, we found it actually very helpful for us, and to go and do fire testing. So we've done all types of fire testing. We've done cone calorimeter testing for commodities under the big cone. We've done small scale cone testing. We've done a lot of full scale testing. And again, it's one of those where maybe sometimes it's to get the bare minimum, like where does that, can we prove the technology of how we differ? If there's something, we stretch the code sometimes. We're not looking per se for, we're not the sprinkler manufacturer, so we're not looking for the sprinkler listing. We are looking really if the fire occurred at our site, would we be able to control it? And control to us can look in a couple different ways, right? We look at it as, I would say, a very complex but simple, right? In the sense of, how do we get to a point where we can keep everything cool long enough so that we can get either our own internal fire brigade or our external fire support to the site to help for extinguishment. So with that, we have, you know, every test that we've done, I think, well, maybe not every, I think we're probably a very high hit rate, or of we have control. What we believe we have suppression, but then we always turn the sprinkler systems off at the end to see if the fire would rekindle. I think anyone in the industry knows that a lot of these incidents have occurred from people turning off the sprinkler system too early. So we'll take what we have, a very controlled scenario, and we will start like I say, at the very end, when it's a great visual, great training that we have where we'll shut the system off, wait a couple of minutes, and what we always tend to have is some type of rekindling. And it goes to the importance then of that, fire response. On the other side is, okay, if we've turned them off, can we still see the fire, or is it up high in a rack? Maybe we do need to leave the sprinklers running longer. The water damage is done. How do we keep things going so that we can actually say that we have full control?
That's fascinating. That's great to hear about, the different fire testing. I mean, it's remarkable that you're involved with a company that, not only, cares for the premium fire protection solution, but also, is kind of stretching the bounds of the building code. I think that it's interesting because the building code is, kind of based on these standard parameters for, the lion's share of buildings, but it really doesn't encompass buildings, the direction of expansion and like development of buildings that we're trending towards with the increased level of complexity. And so yeah, it's really interesting to hear about the way P&G is approaching. It seems like very, I'm used to providing the you know good fire protection solutions and up to code solutions, but you don't always get to provide the premier, like fire protection solutions with fire testing results. So it's really interesting to hear about.
Right. And, our goal is to be cost effective. So when we, again, is okay, so just because we're a couple feet maybe higher in a scenario, in a storage, maybe building height, do we really need to go, install in racks in every level? That type of stuff is like, okay, so where does that, where's that break point for us? And, especially, what if we are, I would say back in the day. So this a great example is we had a site that installed an ESFR system with K22s and in a 45-foot high building. The only issue is at the time the building ended up to be 48 feet. So at the time that this was done, um, we were 3 feet too high from what the code allowed with no in racks. So then the question became, do we install in racks, or do you put a drop ceiling in just to meet that 45-foot high? So we actually went back to the manufacturer, started to ask, where was your limit, where to go? Well, at the time too, um, testing lab, you know, uh, heights were really limited to what everyone thought was 45 feet. Ends up at one of the labs, you could go 48 feet. So we said, well, let's test 48 feet. So we actually went with the manufacturer on that one because they had an interest on what was happening too. So we started doing the 48-foot test, and they actually then got that the K22 as far listed for um, 48 feet. And then, of course, after that, everyone had a 48-foot high ceiling or 48-foot high option. So, and then we didn't have to do anything else. So, other than tests, our goal is our own property protection and business. So, how do we want to protect our assets? And with that, then, we're done without having to go and do anything else to our systems.
That's a great story. That's awesome that you got to work with the manufacturer and, push the limit on the tests. It's funny how, only recently, or I'm not aware of much higher listing for ESFR heads than 48. I guess I would think 50 would be what the max that I'm aware of, but that's pretty tall.
Right. It does. Absolutely.
But so yeah, you talked a little bit about innovation and how Procter and Gamble kind of stays on the forefront of fire protection systems and technology. But I know you've had some experience in the past, and I'd love to hear about how Procter and Gamble works with smart systems and kind of like the advancement of fire protection and the connection of things.
We so this one of my favorite topic. If for some of your listeners too have probably heard me talk about this over and over and over again, but it really, I think our industry has typically been very, I say brick and mortar, but not in a negative way, because I do, I do love and respect this industry, but we are very much, you know, we still have people that have to go walk to read a gauge. Fire pumps running, you still are going to, typically people walking to go to the fire pump. Back in around 2014, so it's been probably about at least 5 to 6 years now, we were, in the industry, there had been a loss at a protected building, and there was a number of things going around. This was a little bit before that time of high challenge warehouses. How do you protect them, right? So because this one warehouse had just burnt to the ground, fully protected, and everyone was trying to do something to change the design of, okay, so maybe, is it not ESFR? There's NRAX, maybe it's CO2, because there's a huge firefighter challenge, in any type of rack storage arrangement. Whether I would argue any, whether if it's, most time people say greater than 45 feet, but I would say any rack storage fire is going to be a challenge. Anything, especially off the ground. Um, and and so I went to one of the symposiums that they did on this high challenge fire, and a lot of people were talking like, well, maybe we put foam in the warehouse, maybe put CO2. And again, they were specifically talking these warehouses 45 feet and higher. My highest warehouse in the company is like 150-ish feet. So I mean, and again, there's no manual firefighting that's going to easily occur again in any warehouse, especially one that is that high in the air. So we started, and that's been a problem for a long time. I can go back to 40, 50 years ago and look at some of the documentation we had about how do you firefight in a high challenge warehouse. So, and no one has the actual solution there. But with that, when we started talking about how do you protect, and I said to myself, I was like, we've done a lot of testing. We've mocked up some of our, what I would consider our high challenge warehouses, those with NRACs, those with NRACs and barriers, those, just ESFR only. We've had very successful fire testing, and the industry has too. So it kind of leads you to, is the design the wrong thing, or is it the response the wrong thing? But then if you put yourself in the firefighters' shoes, as they show up at our sites, there's chaos. There's smoke, there's probably flames and all this type of stuff. Well, from being in the lab and doing testing, I thought, in the lab, we basically monitor the water flow out of the sprinkler head. So it became this idea of, our fire pumps have been giving us data. At the time, I say the fire pumps, but it really is the water flow has been giving us data during all of our incidents that we could give to the firefighter in our incident command to say, you know what, you have control at this time, or you don't have control. And with that, meaning when they show up at our sites, how much water are we actually flowing? Because if I were to look at any fire test scenario where we consider that we have control, I would say that we've been flowing a, say 700 gallons per minute, we've probably been flowing that for 10, 20, 30 minutes, and there may still be a fire, but it's ultimately gone out. So if you look at the fire growth curve, right, we've already hit our peak when the sprinkler system came off, and now we're on the decline. And then the question is, can we keep that long enough? We know in the lab it may still be smoky a little bit, but with enough fire control, we're ultimately getting to that ambient temperature in the area, so that we can then safely go in. And it really is giving firefighters instant command data to make decisions based on stuff that they've never had before. We're not going to lead them. They actually have control of the scenario, the situation when they come to the site. But this is just providing them with stuff because, again, one of our PVPs, our principles is, we're protecting people, and that includes anyone who comes on our site, right? So if firefighters come on our site, we don't want them to, to we want to empower them to make wise decisions on what they can do while still, being protected. So at that time, we worked with a pump manufacturer. Came to us and said, don't you want to know everything about your fire pump from remotely? And I was like, I kind of joked. I said, not really, because, but we came to this conclusion of, once we gather all that data, we can easily start monitoring fire pump performance. So it started off on if the fire pump's telling us what's happening during the event, let's gather that fire pump, and we can, possibly do a curve or something. But now it's gone to on part of this app that we have now with Fire Connect. We actually can look at this app, and during the incident, we can it's almost like an EKG, right, type deal, where you can actually see how much water is flowing during the incident. So we have an incident command page of it, so we can monitor it. So if fire department shows up, you can pull it up on an iPad, and you can say, you know what, we have a fire in this warehouse. We are currently flowing 500 gallons per minute, and we've been flowing 500 gallons per minute for the past 10 minutes. On this app, you can see our fire pump is running. It's operating, properly. We've been trying to put any of the major warning signals on there. We actually have also a schematic of the water tank. So again, if you tell someone, like, let's just let things run, well, with this, we can actually, on the water tank, we're calculating and giving that incident commander how many minutes of water we have remaining based on that flow rate. So we may be refilling the tank. Doesn't really matter. We're taking head pressure on whatever is existing. So hopefully, if the refill's open, it'll just continue to calculate minutes per the level. That doesn't mean that we're not going to go check it visually if it's a long test or a long fire or a long event, but this way we can actually go do that. And then that's actually grown. Now, just our upcoming thing that we're piloting is trying to be more sustainable with it. Now that we have a water flow meter, like where we can tell how much water is flowing, our next goal is how do we stop dumping fire water just on the ground? So we're actually going to take our cooling water discharge, like per code, you're allowed to put it back to the tank as long as you're, again, monitoring temperature and flow off of that. But in wanting to be able to monitor that in a way that we still maintain full protection, right? We don't want to do, I've always had this thing as cool as it may be to do, we don't want to hinder our ultimate goal of, providing the protection for what it needs. So as cool as it may be to digitally monitor certain things, we don't want to lose a fire pump because we were just being cool. So in our sustainable world now, so we're going to start piloting digitally monitoring that cooling loop back to our app, and then go and stop dumping cooling water discharge on the ground each week. And then from there, we can start, take the fire pump, loop test, all types of stuff is dumping it back because we'll have, yeah, in theory, our own, pressure flow that we can pull digitally on the system. So, and then on top of that, one of the greatest things about all this digital stuff is instant notification to our site leaders. They don't have to rely on just the guards or the main fire alarm panel saying fire pump running. We can get a text notification, fire pump running. They can pull it up on the app. They can see specifically what's there. We even have pump house temperature now, right? So before we just monitor low pump room temperature. But you can imagine low pump room temperature, depending on where you are in the world, means different things. So, in some cases, as we're monitoring just below 40, is 39. Our sites up north, 39 degrees is not going to make them crazy. Our sites down south, 39 degrees may start to make them crazy, right? So, again, if that happens, our site leaders can now just pull it up on their app, look at it, and really when they're looking at their app with the Fire Connect system, they can see everything that's, they basically can see the whole fire pump, jockey panel, everything. If the fire pump is running, they see that on there. They can actually go and look at the water flow. Is it just running, or is it running with water flow and how much water? And then make decisions based on that too.
Wow, that's a lot of data.
Yeah, that was a lot of talking all in one thing, but yeah.
No, that's awesome. I'm great. I'm so excited. The whole point of this show is to, talk about subjects you're passionate about, and I love hearing about you talk about, getting excited about being
Yeah,
able to provide all this information and this data, and not only be able to run facilities more effectively and more safely, but also protect, members of the fire service. I mean, there's
right.
not too many more noble pursuits than that. But no, I
Absolutely.
loved hearing about all those things. I'm taking notes over here and
Yeah,
thinking about follow up questions. But I love data. I think that fire protection is going to be, trend as I think the whole world is on more data driven decisions. So I
right,
really liked hearing about the different points of data from the fire pump and the fire protection water storage tank. I think
right.
that's really interesting. I'm a big suppression nut, so really like hearing about um, extrapolating all those different data points from
Yeah. Well,
the FE systems.
yeah, and you actually just learn. So one of the things that we have that, you know, I'd say data learning is, jockey pumps. We monitor and have a graph of how many times the jockey pump started. So that data has always been in the controller. A little harder to get, without unless you go hit a bunch of buttons or download the data and read a text file. I mean, but this is a visual, and what we're doing now too is actually text notifying when the jockey pump starts running more, a percentage based over what is normal. So, so if our normal is say 15 times a day, but all of a sudden we're up to 50 times a day, then obviously something's going wrong. So it's going to be a little bit more predictive instead of waiting, to it other than because again, not many people just hang out at the pump house all the time. Weekly they come in, it's like, how long is that jockey pump running, right? There's not that easy um, predictive monitoring, I should say, for that. But we're also doing one of the things we're doing is on our risers, we're piloting also. We put some gauges to basically read our gauges on our risers. And it's been fascinating because at each riser, um, it normal operation at that gauge and the lower gauge of the check valve, right, is right there following the jockey pump on and off. What we've learned now too is if a valve is shut going to it, which obviously seems very simple, but if we shut a valve, really within the cycle of the jockey pump, I can get a notification to my site leader that there's low pressure on that system, which is really fantastic if you look at, I think, a couple things, just the whole system reliability. Did my site leader know that riser, was going to be closed? Was it going to be, did they know that they were doing work on it? And that's been all the cases so far. But if some reason something was shut for an unusual reason, they would be able to get that notification really as it's occurring. And again, it's not just that, hey, for the tamper switch being more supervisory, saying, hey, something happened, go check it. In this case, we would actually monitoring normal pressure or normal health of the system. It tells us when things are, again, trending off. So it's been really fascinating to see, well, fascinating for some of us, right? To see how these things, right? So I think some people were like, okay, that's great. Systems are,
No.
but no, even when if we turn the jockey pump off, how each one goes. And even for our sites, you can imagine our sites are quite large, but the differentiate, elevation pressure, normal C, right? One system may be 150, one system may be 146, right? But we don't, when we're doing this and we can see it graphically, we can actually, we can see all those differences versus when you walk around, it's like, yeah, it's 145-ish, right? So we're getting a little bit more data. And our goal there really is, it allows us, so we tied this, which is, we're using a system from Cypress, environmental systems right now, where it's just like a clip-on gauge to our existing gauge, but we've actually taken that data into that Fire Connect Smart platform. So again, when we go back to incident command, if the incident occurs, you can actually access that, all the riser pressures if you wanted to by a click. But what we're doing also with that is it allows us to build in that click, you can get real-time pressure. But what I can do is again, we've just started this out too, where we have fields in there to say what is the hydraulic information. So if you think of your hydraulic placard, you can actually, we're typing all that into this real-time data. And the point of that being is we go back to the incident command and monitoring water flow. So if I tell, the fire department, hey, we're only flowing 700 gallons per minute, maybe we should just wait, right? But what it'll do is to say, we know riser 5 is in alarm, right? Is the water flow switch. So we can then pull up riser 5 on this dashboard per se. And if we've added all our hydraulic information, we can then tell them, hey, riser 5 has ESFR heads and it was designed for a total flow of, 1,271 gallons per minute. So we're only flowing 700. We still have some heads to operate before we get in concern area. Because I think what happens right now is, we'll open some heads. We don't know how many heads are opening. We don't know how much water is flowing. We just know that there's fire, there's smoke, and the fire pump is running, right? So in this case, we're trying to, again, give that data. But we pay a lot of money for sprinklers to be designed for 12 heads at 50 psi, whichever. So, we're not going to have concern. Well, great concern until we're pushing that limit of the design. So, if that makes any sense. So this way, we're giving that data, even if we were right at, maybe we're flowing 1,500 and the design was 1,200. There's still a level of concern, but if it hasn't changed, then it's like, okay, but our level of concern is going to be greater if we're flowing more water than only one head at 5, so.
That's awesome. I really like hearing about the different. I loved your comparison to like an EKG of the fire pump. I was like, that's so telling of, the kind of data and the sensing of all the hydraulics. I'm picturing all this in my head as you're describing it. I really liked how you talked about the jockey pump, and that kicking on and
Hmm.
knowing if the valve was shut. I mean, wow, that's incredible. I mean, for a number of reasons,
It's
inspection,
so
testing, and
cool.
maintenance,
Yeah,
but
yeah, no,
also I mean, like you said, what if somebody didn't mean to shut it off and they shut it off, or what if somebody intentionally meant to shut it off and it wasn't supposed to be off,
right.
like all of these things. So yeah,
And
that's really interesting.
even if they meant to shut it off, is it back up and running? So I've got some graphs now that I can see, like normal operation, valve shut, work being done during the day, and then really you can go back up to um, when it's back on, it's back to normal operation, right? So again, my site leader, where we're piloting this, can actually just pull up um, their data, right? And their dashboard on here and say, yep, they turned it back on, because it's not a question of, what is like it's back up to normal operating procedure. So, but yeah, you hit it. You're exactly right. So we're looking at this. Our main goal is um, reliability, right? How can we make sure that we have reliable systems? Of if you look at the major losses that have occurred, normally it's a shut valve or turned off water supply, right? So um, losses that can occur. There's a number of losses, that can occur because of obstruction or this and that, but are things that really make a difference in how a normal loss incident would change from normal to maximum, or MFL type event, would be that there was no water. And so that no water comes from valve shut, so no water to the system, and or your water supply fully shut. So by, again, us monitoring those critical things, we have a higher level of assurance that our systems are reliable and operating, as goal number one. And then two is, as you said, inspection, testing, and maintenance. So now I think we're going to be able to get to a more performance based on some of that. As again, do we really need someone to visually go check a gauge monthly when we're really pulling the data every 15 minutes now, right?
Wow.
So we can stop, having people, whether our people, contractors, anyone, stop walking around to, take a clipboard and paper and write stuff, and even flow testing. If as we're digitally capturing that information, again, trying to not dump it on the ground, but also get good data from the digital systems. Can we can just plot out last year's test curve versus this year's test curve, right? Without having to worry about the gate. Anyone who's ever done a fire pump test knows, that gauge needle moves a lot. So it's as simple as that, right? Of like, okay, so is that range of 150 to 160? Let's go with 155, right? But well, as we're pulling, especially the fire pump stuff with sensors, it it does eliminate a lot of that guesswork, and we can actually take then good data curves and compare them to each other.
Wow. Yeah, I can't tell you. This is I don't know if you can get much more right up my alley than fire protection systems and suppression and data. But I want to be respectful of your time, and yeah, I just want you to know that I could ask you questions about this stuff for another 2 hours. But
We can
I
talk again. No worries.
yeah,
Absolutely. Yeah.
that'd be awesome. But
It's
yeah, I
all.
just want to thank you so much for coming on the show, and yeah,
Uh,
it's been awesome.
yeah. Thank you, Gus, and best to you.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.